Okay, we continue with the part B of the transformer, okay, which is ideal transformer. It's basically just a very simple transformer. First thing you need to know about induced transformer, about the ideal transformer is the induced EMF. Okay, induced EMF is basically the voltage across the winding. Okay, you have to memorize this formula. E equals to 4.44 F and flux. Okay, N is the number of turn at the winding, either winding primary winding or secondary winding. Okay, flux M is the maximum peak flux, and F is the frequency of the supply. Okay, so for ideal transformer, EV is usually E equals to V. Okay, what is this mean that? Okay, so I show you this. So you need to know how to draw the transformer. So to draw transformer is basically you draw a something like this and then something like this. So you have the winding, and then you have another winding. This one is the input, this one is the output. Okay. What is mean that E and V is that, okay, both are voltage actually. So both are voltage, but usually we say that this is the E. At the winding, we call it E. Either you can call E1 or E1 is basically E primary. Okay, either you call it E number 1 or E primary. Okay, this one is the E2. Okay, E2 is basically E secondary. So make sure you know the term. 1 is usually for primary and 2 is for secondary S. Okay. And then usually we said that V is here. Vs at the output, at the wire, not the winding. So this is V1, this is V2. So make sure you know the difference. Usually this one is for the supply. Okay. For ideal, okay, for ideal V1 is equal to V2 because there is no component, no other component. Okay. Same here. E2 is basically V2. Okay. Why? Because there is no component. For this, because this is ideal. But for non-ideal, okay, for non-ideal, there are component here. Okay, there are impedance. So when there are impedance, voltage at V1 is different from, okay, non-ideal or practical. Okay, V1 is sorry, this one is E, right? E1. This one E2, V2. Okay. So V1 is not equal to E1. Okay. So make sure you know the difference. Okay. This is just how to differentiate the symbol we use. So the voltage here, okay, this formula only useful if they involve flux. Okay, this is the flux. Okay, if they mention flux, you have to use this formula. If they don't mention the flux, no need to use the formula. Okay, some question involve flux. Okay, peak flux. Okay, you only use the peak flux. If there is no involvement of flux, you no need to use this formula. Okay, and then this is the important one because we will use this a lot. Okay, actually most of the question are usually on the turn voltage current impedance relationship. Okay, this question is not given. You have to memorize it. Okay, make sure you memorize the equation. So basically it's simple. Number of turn, n is the number of turn. Okay, n1 divided by n2, okay, is equal to E1 divided by E2. Okay, so basically it's follow. But for current, you have to be careful. Okay, for current, you have to flip it. Okay, you can see here, 1, 1, and then suddenly it is flip. For current, you have to make sure that you flip it. And then for Z impedance, okay, it's still the same, 1 and 2, 1 divided by 2. But you have to put the square root. Okay, you have to put square root and equals to A. A is actually a turn ratio. Okay, you can use this. Okay, the turn ratio. Sometimes it is easier to use turn ratio. So turn ratio is basically N1 divided by N2, or E1 divided by E2, or E2 divided by I1. Okay, make sure you know this one. Okay. Another thing you need to know at the ideal transformer is that how to refer to primary side and how to refer to secondary side. Means that, okay, all the parameter you bring to the primary side. Okay, this one refer to primary means that you bring all the parameters to the primary side. There is no more transformer. Okay, just to simplify the circuit. And then this one is referred to the secondary side, means that all the parameter goes to the secondary side. So there will be no transformer. Okay, make sure that you know that when you bring to the primary side, it is represented as primary or secondary side, it is represented as this one for impedance only. Okay, for impedance, when you bring something to the other side, make sure you put this. Okay. Okay. So I give you example for ideal condition. So a transformer coil passing through 400 turn, 4,000 turn and link an AC flux having a peak of 2 milliweber. If the frequency is 60 Hz, calculate the effective value of the induced voltage. So basically, a transformer, okay, something like this. Okay, and you have winding here. Okay, the number of turn is 4,000 turn. Okay, and the flux, okay, the flux here, the flux is the flux maximum. Okay, the peak flux means that if you have flux something like this, because this is AC, the flux will be changes. So flux maximum is basically at the top. Okay, you take the top value only. So flux maximum is 2 milliweber. So be careful, milli. Many of you are making a mistake in the test 1 and test 2 on the prefix. Okay, make sure you know what is milli. Okay, frequency is 60 Hz. So remember that I said when it comes to flux, you have to use the formula. So E equals to 4.44 F and flux M. Okay, so just insert the value 4.44 F. Okay, F is 60, N is 4,000, and flux M is the 2 milliweber. So 2 milli you can put 2 multiplied by 10 negative 3. Okay, make sure you know what is milli. And then you get 2131.2 if not mistaken voltage. Okay, you get the voltage here. Okay. This one, the voltage across this plus minus E. Okay. So that is how you get the induced voltage. Okay, this is the step. Okay, you just use the formula. Okay, this question is usually not asked. So you can understand it, but it is usually not asked. But make sure you know the formula if the question asks you to find the voltage or find the flux. Okay, usually either way. Now we move on to example 2. Okay, an ID transformer is connected to the 3 plus 4J load. Okay, you have 240 supply at the primary side. The first and second winding are 1500. Okay, draw the equivalent circuit that refer to the primary and secondary side. So how to do this? Okay, so you have a transformer here. Okay, you need to know how to draw transformer. Okay. Okay, you have load here. And then you have a supply here. 240 volt, and then you have 3 plus J 4. Okay, this is the figure. So the equivalent circuit is basically, if you draw this back for ideal, okay, make sure you know this. Okay, for equivalent circuit is basically something like this. Okay, 3 plus J 4. So this is equivalent circuit. This is figure. Okay, make sure you know the difference. Okay, so you have I1, this one is V1, okay, and then this one is E1, and this one is E2, V2, okay, plus minus, okay, plus minus, and then this one is ZL, okay, ZL means that load, okay, L means load, okay, make sure you know what is L. This is the standard one. I2, and make sure the direction is all to the right of current. So the question asks, draw a equivalent circuit refer to primary and secondary. So this is just a equivalent circuit. Okay, this is just the equivalent circuit. Okay, if you want to refer to the primary side, basically all of these, okay, all of these bring to the primary side. So how to do this? Okay, why we want to either bring to primary or bring to secondary is basically we want to cancel this. Okay, so we want to eliminate this, the transformer, so easier for you to calculate. So if you bring this to the primary side, is basically, okay, bring to primary side, everything in the primary side, you just leave it. So you get V1, okay, you get I1, so just leave it. And then this at the secondary side, there are Z, okay, ZL, okay, so become this one, ZL. Okay, remember that when we bring to the secondary side, it will become, okay, any impedance that we bring to other side, make sure that you put this. Okay, you put the comma at the upper side. Okay, and then this is for refer to primary. Okay, we cannot just leave like this because we have to calculate actually. So V1 is usually 240. If they give the value, make sure you calculate. Okay, V1 is 240. I, you don't know. ZL, you don't know also. So how to calculate this? So use the formula. So remember, we have the number of turn. Okay, we have to make sure that we use the component that's already complete. So number of turn, N1 divided by N2 equals to square root of, okay, Z1 divided by Z2. But for this case, we use ZL. So, okay, Z2 is basically ZL. Okay, but Z1 is basically ZL, comma. Okay, I forget the name. Yeah. So you have to use this formula and you want to find this. Okay, you already have N1, N2 in ZL. So ZL equals to, okay, N1 divided by N2 squared ZL. Okay. So ZL, comma, okay, is 1000 divided by 500 squared 3 plus J4. So you get ZL is equals to 12 plus 16J. Oh, so you get this. So 12 plus 6J16. And how about the current? So you have the voltage. Remember that voltage across here is the same because there is no other component. Okay, so I1 is just equals to V1 divided by ZL1. So I equals to 240. If they give only this, make sure that you put 0 degree. Okay. Okay, divide by 12 plus J16. Okay. So the answer is, so use your calculator to calculate this. I don't have any calculator. Someone please calculate this. Okay. Oh, I think there is answer here. Okay. Oh yeah. So this is the step. Okay. You get 12 point. Okay. Okay. 12. Oh, 12 angle negative 53.13 degree ampere. So this is I1. So you get, here is 12 angle negative 53.13. Okay, that is refer to primary. Okay, and the question asks you refer to primary and secondary. So you have to show both. So for refer to secondary, okay, refer to secondary side. So basically, okay, the load is just leave it right there, and then you have a voltage. Okay, this one is V, not V2, but E2. Okay, and then you have I2 and then you have the ZL. This is refer to the secondary side. So you bring, because there is no other, if you look here, there is no impedance. Okay, only the parameter voltage and current, just bring to the secondary side. So just draw like this. And then you have to show what is E2. So remember that for ideal, V1 is equal to E1. So for E1 divided by E2 equals to N1 divided by N2. So E2 is equals to N2 divided by N1 E1. So N2 is 500 divided by 1000. Okay, multiply by 240. You get 120 volt. So this one is 120 volt. So how about ZL? ZL just use back the value 3 plus J4. And the current, same thing, either you can use I2 divided by I1 equals to I, okay, N1 divided by N2. Okay, you can use this, okay, or you can just use the formula I2 equals to E2 divided by, okay, divided by ZL. Okay, you get the answer. Okay, that's it. This is only thing yet you need to know on the ideal transformer. Okay, so we take a break, and we will continue a little bit on the next chapter and next subtopic. Oh, there is another example. So wait, we continue with another example before we proceed. Okay, somebody have any question? Okay, so we continue with the next part. Okay, example 3. Okay, I forget this is available. So this is example 3. Okay, you have a 1 kilovolt, 1 kilo kVA ideal transformer supplied by 415 volt and operate at full load condition. Okay, full load means that the rating is full load. Okay, this is the rating of the transformer. 1 kilo kVA is the rating. 1 k S equals to 1 kVA. Okay, so this is the rating, and full load means that it will use all. Okay, and then you have PF is 0.85 lagging. Okay, and then number of primary turns is higher, 3 times higher than the secondary turn. Means that N primary is equals to 3 and secondary. So make sure you know how to extract the information. Okay, PF. So supplied by 414. So V1 is equals to 415 volt. Okay, another. Okay, that's it. And then how to calculate this? So this one you change it to NP divided by N secondary equals to 3 equals to A, turn ratio. Remember the turn ratio? Okay, use this. Okay. So NP divided NS is 3. So the voltage, calculate the secondary voltage. Okay, because this is ideal. Okay, V2 is equal to E2. Okay, equals to, this one is equal to E1. Okay. So remember the formula. E1 divided by E2 is equal to A. Okay, you have E1. Okay. So E2 equals to E1 divided by A. So E2 is 415 divided by where is it? 3, right? So A is 3. So you get, so I check back here. So 80 volt. Okay, you get the first question. What is the secondary voltage? Okay. Next, calculate the load impedance at the primary side. Okay, you know that S is equals to, okay, S equals to 100 V A. Okay, and then you have PF equals to 0.585 lagging. Okay, so you don't know the Z because in this formula we only use, okay, remember the formula of the transformer, we use Z. So you don't know Z. How to get the impedance Z? So you have to use, okay, remember the complex formula, S equals to, okay, you have V, right? So V squared divided by Z. Don't forget the conjugate. So Z equals to V squared divided by S. And then don't forget conjugate. So S, what is S? So you have to find the theta. From this, theta is equals to, okay, remember cos theta is equals to PF. Okay, PF already given. Okay, so theta is equal to cos inverse PF. And remember lagging, okay, when it comes to theta, okay, lag positive, lead negative. Okay, so this is positive, because this is lagging. Okay, make sure you know. So lag is positive, lead is negative, the theta. So theta is cos inverse 1, 0.85. So the answer is cos, where is it? Okay, this one. 1.79. So use this formula. Z equals to V2. Okay. For we use the V2. Okay. Z is ZL, right? ZL. So V2 is 80, right? 80 squared. And remember, don't put any angle. Okay. Don't put any angle when it comes to square. Okay, and then divide by the S is 1000. Okay, the angle is 31.79. Okay, remember S is equals to S angle theta. Okay, this is complex power, and this one is apparent power. Okay, complex power are usually volt. Okay, we use volt. This one is should be volt. Okay, volt also. Okay, then you get Z equals to, and don't forget conjugate. Okay, use your calculator. Okay, for this one you get, okay, 5. You get where is it? 5.44 plus J 2.37. Okay, be careful with the conjugate. Okay, you can see here. Okay, if you can see here, conjugate, if you calculate this without conjugate, it is negative. After you conjugate it, it will become positive. So be careful. Okay.
Doctor,
Yes.
the question is 415, but the answer sheet is 240
240.
for the voltage. But the question is 415.
415. Oh. Okay. Change this to 240 lah. Think wait. Let me check. Yeah, all the step is 240. So change this one is 240. Okay, either change this or change everything. So easier to change this only. Okay. And then calculate the load impedance at the primary side. This is the secondary side. So you have to use the formula. Remember the formula. Okay. Make sure that you use the formula here. Okay. So remember N1 divided by N2 equals to square root of Z1, or for this case ZL, this one, divided by Z2, which is ZL. So ZL1, ZL, I forget the name, okay, equals to N1 divided by N2 squared ZL. So you just insert the value. N1 is what? N1 is 3 times. N1 divided by N2 is 3. So this one is 3 squared. Okay. This one is A, right? So 3 squared. ZL is 5.44 plus J 2.37. So you will get the answer. Okay. Okay, you will get the answer. Okay, and then the primary and secondary current. Okay, this one is as usual, like before. So I2 is just E2 divided by Z2. You get the answer. And for I1, you can use either this method or V1 divided by E1 divided by ZL apostrophe, right? So you can use either way. Okay, the answer will be the same. Okay, that's it for ideal. Okay, and I think for today, just until ideal. If too much, I think you will get confused. For practical, I will show you in the next class. Okay, the ideal one is much more harder. Okay, there are a lot of things you have to consider when it comes to ideal practical transformer. Okay, so for this case, only focus on ideal first. Try to understand, and then in the next class, we will discuss about the practical transformer. Okay, for those who still doesn't check in your attendance, okay, make sure you check in your attendance. Okay, I think okay, the class is ended. Okay, thank you.
Thank you, Doctor.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Thank you, Doctor.
Okay, welcome.